Okay, in this session we're going to talk about patent documents and patent data fields in particular. So when we think about the question, what is a patent, I guess we can describe it in two main ways. The first is as a particular form of intellectual property right, and the second is as a type of document. Now, I'm not going to go into the details of a patent as a form of intellectual property right, and as you can see there's quite a lot of text here, but basically it's a temporary grant of a right to exclude others in jurisdictions where a patent is in force. The patent rights are territorial in nature. They only apply in jurisdictions where a patent is in force. Generally last for around 20 years, but they can be opposed or revoked. And there are a whole set of eligibility criteria. Now, for the purposes of patent analytics, we really need to think about patents as a type of document. So there are two things here that we need to understand. The first is the structure of patent documents and the data fields within a patent document. And the second is the strengths and weaknesses of different patent databases as a means for obtaining patent data. And I'm going to talk mostly about the structure of patent documents in this session. So we have seven basic data types, and I'll go into these in a little bit more detail. So we have a range of dates, we have a range of numbers which serve as unique identifiers for documents and allow us to track the relationships between documents. We have names, notably the names of applicants, who are also commonly called assignees, and the names of inventors. We also have the names typically of patent lawyers or attorneys. We have classification codes such as the International Patent Classification and the Cooperative Patent Classification, which allow us to find documents in specific areas of the patent library system. Then we have free text fields, the title, the abstract, the description, the claims, and for example DNA sequence data. Then we have images, typically diagrams, and finally we have a set of additional information such as legal status information or information in public registries linked to patent databases. Now I'm going to use an example that a few years ago was quite controversial from the Craig Venter Institute in the United States, which is the quest to create synthetic genomes as part of the pursuit of the creation of synthetic or artificial life, as it's being called, with the rise of what's also called whole genome engineering being a significant area of debate and controversy. Now, what we have here is the front page, also known as the biblio, of a patent application from the Venter Institute that relates to synthetic genomes, which provides methods for constructing a synthetic genome comprising generating and assembling nucleic acid cassettes from portions of the genome, and those are then stuck together in various ways. Now I'm going to dwell on this front page for a couple of minutes because here we have 6 sets of data. Now the first set of data that we have are numbers as identifier numbers. So we have the international publication number, we have an international application number here, then we have priority data, where if we put the country code US onto the front of that, we'd have US 60 742 542. Now in practice the earliest of these numbers is here, priority data, followed by, that dates to 6th of December 2005. That then leads to an international filing date for an international application in December 2006. And finally, the international application is published on the 28th of February 2008. So that also covers off our second set of data, which is dates. So note here that we go from our priority date, the first filing date in 2005, That is then submitted internationally in 2006 and is then published in 2008. And in the process, a set of identifier numbers are generated. So we start with US 6742542 here. That then moves to become PCT US 2006 X, Y, and Z. And then we have this formal international publication number here. The third set of data that we have available is names. So we have applicant names, in this case the J. Craig Venter Institute. Notice the additional information that's in the brackets here, which is the country code for United States and the actual address, again with the country code here. Then we have additional applicants, which is Clyde Hutchinson with the address and additional country information. Then we have inventor information, which is the actual inventors of the claimed invention, again with some address field data that we could use for other purposes. Then we have the patent agent information with address field data. We won't worry about the designated states. The fourth category of information that we have is the international classification. In some cases you will see the cooperative patent classification as well. I'll come back to that. Now, these classification codes basically tell us about the technology area or areas that are involved in a particular application. So in this case, C07H tells us that this has something to do with nucleic acid. C12P is going to be something in general terms to do with biotechnology. C12N506 relates to some aspect of biotechnology that relates to animals, I believe. So if we looked these actual codes up, we would get quite a precise description of the technology areas involved in this particular patent application. So the next set of information that we have are text fields. There are just two here, which is the title in capitals. Then we have the abstract, which we could use for text mining. We also have an image down here which relates to one of the assembly of one of the nucleic acid cassettes, but we don't have other information just on this front page. So now let's look at exactly the same information in the Espasnet database, and I'll just point out that these blue markers here, if you click on those, these will actually take you to the document in Espasnet. So here we have basically the same information as is contained on the front page. Notice the country codes here next to the inventor and the applicant names. We have both the international classification and the cooperative classification, and if we were in Espasnet we could click on those. We have the priority information, which has now been transformed slightly with the country code on the front, the dates here at the end, and the P here means provisional patent application, I believe. That then leads to our application number, which a couple of years later leads to our publication number. Now, the publication number is almost always the easiest information to obtain, but we need to just keep an eye on the relationship that here we have our first filing, here we have our submission of our international application, then we have our publication of that international application. So as we can see here, we have a nicely structured approach to the patent document. So the next thing we will see is the description. Now this tells us about related applications that have been submitted, mainly provisional applications on introduction of genomes into organisms, error correction methods, and so on. This tells us that this was federally funded research, and further down we'll have a lot of text fields that provide a lot more detailed information. Now the real meat is in the claims, Particularly, we need to pay close attention to claim 1, which frames the rest of the claims. And so here we learned that this is a method for constructing a synthetic genome that involves assembling nucleic acid cassettes. And then we'll have a whole set of subsidiary claims stemming from claim 1. So this, of course, is particularly important for text mining purposes in establishing what an invention is actually about and what is actually being claimed. The next piece of information is the family information. This can quite often be difficult to obtain from public patent databases. Here we can see that there are 9 applications that link back to our original first filing, our priority filing. And here that's the international application. Here we have an application in Australia. This code here is B2, is telling me that this became a patent grant. We also have a Canadian and a Chinese application. So this family data is actually telling us where else in the world this particular application has been pursued. Following the link from the priority document through the international application onto the national jurisdictions where a follow-on application has been filed. Now, it's important to bear in mind that patent applicants typically stand on the shoulder of giants. That is, those giants are earlier patent applicants typically, and here in the cited documents field we can see the existing patent filings that are shaping this application and limiting what can be claimed as prior art. There are actually 2 sets of information here. So we have a couple of patent applications, this one from Aegea Biosciences, and we also have one, and then we have 2 literature science citations, which are non-patent literature, one from Nature and the other from, in fact, the inventors of this application. Current application. So cited documents limit the scope of what an applicant can claim, but they also provide us with really interesting information about technology areas that are shaping a particular emerging area of science and technology. So we can also see what impact an individual application is having on other applicants within the patent system through the citing documents field. So we can see here that a 2014 application coming out of the UK from Discover for bacterial engineering is citing the original Ventor application, as is another application actually from the same applicant, Synthetic Genomics, also in 2011. So here we're getting an understanding of what is the impact of a particular filing on other applicants in the patent system. So the final piece of information, and this is notoriously difficult to interpret, is legal status information, which tells us what the events are that are associated with them. There are a set of relatively, I think it's fair to call them obscure codes that link to this, but this can be very important information. So, to round up, what we've done in this session is we've walked through some of the most important of the patent data fields. In practice, those fields are the building blocks for sophisticated patent analysis. So what we're going to do in future sessions is focus on retrieving data with these fields. Then we're going to clean up that data. We're going to map trends. We're going to map networks. And then we're going to finish off with geographic mapping. Now, if you'd like to learn more, you're welcome to visit the project homepage on GitHub. You can access the materials directly on GitHub, and you can also, of course, you're very welcome to add your own materials. You can also contact me with comments, corrections, or suggestions. Thank you very much.